Hi everyone. In this lecture, we'll learn to handle media data with Firebase storage. The motivation is that we want to let users sign up with their profile pictures. An attractive feature of Firebase is its real-time data handling ability, as we saw last time. However, before Firebase 3, that's only useful for non-media data. For example, for photos, people had to turn them into string format, then store them here, just like we store emails and usernames. Then do the reverse when pulling them back. That's not suitable for real-time application because it's time-consuming. A workaround is to hook up your own data storage with Firebase database, but that's not really easy. But things are much simpler now with Firebase storage. Firebase storage is just something you can directly store media files such as photos and videos, then handle them in real time with Firebase database. Precisely, after we push media files to Firebase storage, we get back a URL using which we can access our files. We then store that URL in Firebase database, just like others in string format, and exploit the real-time feature of Firebase database. That's the big picture, so let's do it. As usual, to work with Firebase storage, we need something from Firebase. Let's put down in the pod file that we will need to use the Firebase storage package. Okay. Then head to the terminal to install this package using pod. We use the pod install command to install whatever we specified in the pod file. It's installed the Firebase storage package. Okay, it's finished. Let's just leave it there for now. We need to take care of something first. In the signup view controller, in the signup button method to be precise, we get the username and email from a user to create a Firebase user object. Then push the Firebase user to Firebase database. So the user database now only stores user emails and usernames. Now we also want to let users tap this UI image view to pick a profile photo, so we can then store this photo on Firebase. So our plan now consists of two big steps. We first let the user choose a profile photo by tapping the UI image view, then push that photo to Firebase storage and store its URL in Firebase database. All right, let's do it. First, let's set a goal in the middle and work towards it. Let's just say the user successfully picked an image from the photo library. How do we keep the photo before pushing it to the database? So let's write an extension for that purpose. We use this extension simply to add more methods to the signup view controller. You can do this business above in the body of this class, but using extensions in this case makes the code more readable. Now, it's convenient to let this signup view controller receive the chosen photo from the photo library. So we let it conform to the UI image picker controller delegate and the UI navigation controller delegate protocols. You'll see why these two shortly. These protocols provide some useful method for us to receive photos selected from the photo library. Precisely, option-click the UI image picker control delegate protocol. We can see an optional method called image picker control. By conforming to this protocol and implementing this method, our signup view controller can get access to photos selected from the photo library via the info parameter at the end of the parameter list. All right, we'll see how things work shortly. In the extension, let's let the signup view controller implement this method. All right, good. If a miracle gives us a tool for picking photos from the photo library, our signup view controller can access these chosen photos inside this method. We can then push those photos to Firebase storage and database. Of course, there is no miracle doing that for us, so we must do that ourselves. Our plan now is that when a user taps the profile UI image view, we'll present image picker, basically show the photo library for the user to choose an image. So we need an action to respond to users' taps on the UI image view. However, by default, a UI image view doesn't respond to user taps or things like that. Therefore, we must add some sort of responsive ability to our UI image view. Intuitively, we would need to define some sort of user gestures that we would want this UI image to respond to, like tapping or things like that. We then let this UI image be able to recognize this gesture and act accordingly. Finally, we make this ability of the UI image available to use. Alright, let's say someone gave you a device to recognize some kind of gestures. We can add this device to the UI image, which is the profile image property in the source code, using the add gesture recognizer method. Of course, no one is going to give us that device, so we need to create one. In this app, we want users to tap on the profile photo. So let's create a device or object for recognizing tap gestures. We do this by creating an instance of the UI tap gesture recognizer class. There are two parameters, a target and an action. The action is what should be done after this device recognizes a tap, and target is something that performs this action. Here, we use self, which is the sign-up view controller itself. Alright, if you option click this UI tap gesture recognizer initializer, you'll see that action is of type optional selector. This selector identifies the method that will be implemented by the target, which is the sign-up view controller. We'll implement this method shortly. For now, let's just say we have it already. Because we want users to select a profile photo after a tap is spotted, let's name this method handle select profile image view. It's entirely up to you to name this method. Alright, this error is expected, right? We haven't implemented the method in the selector. So let's declare it to silence the error. It's going to be a method of the signup view controller as we stated clearly above that. We want the signup view controller to perform this action. Alright, great. Now we have a tap recognizer. We now need to add it to the profile image object. You can either chain things like this or declare a constant to hold this tap recognizer. Let's say tap gesture. Then add this constant to the profile image property instead. Alright, good. We'll decide what to do after the tap shortly. Alright, now let's just make the profile photo responsive. Actually, to make sure things hook up properly, let's print something out to indicate that. Alright, the UI image view does indeed respond to our user taps. Let's run the app. In the meantime, let's think about it a little bit. Although the UI image now can recognize a tap, we still need to make sure if it is able to feel the tap before recognizing it. Anyway, let's check it out. Let's tap on the UI image view. Alright, nothing happens. This UI image isn't even aware of this user interaction. That ability of UI image controller is disabled by default. So let's turn that ability on via its property named let's search for interaction. Alright, yep, this one. The property name is user interaction enabled. Let's set it to true so that our UI image view can feel user interaction. Alright. We let the UI image be able to feel user interaction and add its ability to recognize if that interaction is a tap. If that's indeed a tap, then we let the signup view controller do something. Okay, let's tap the photo. Fantastic. Now let's decide what to do after a tap. As in popular apps out there, after a tap, we want to show the photo library for users to pick photos. That's why we want the signup view controller to perform this action. We're gonna let it present a photo picker. Let's name it Picker Controller. This image picker offers a user interface to choose media files from the photo library of our iOS device. Swift offers a class for such purpose, named UI Image Picker Controller. You can see what this class can do here. Alright, let's initialize an instance of this class. It's going to be our image picker. Now, let the signup view controller present this image picker controller. Simply search for present and look for method that presents a view controller. Alright, again, we use this signup view controller itself to present this picker controller. Allow animation and do nothing upon completion. Alright, you can also use the self keyword here, but the system can infer that the signup view controller is calling the method. It's a good practice to skip the self keyword unless you are required to use it. Alright. Okay, here it is. Okay, let's tap the profile photo, and fantastic. This is the image picker we're talking about. It allows users to pick photos and videos from the photo library of their iOS devices. All right, we selected a photo, but where is it? That's the reason why we let the sign-up view controller conform the two protocols that allow it to access the selected media files. In particular, the didFinishPicking method will be executed after a media file is selected. Let's print something out to see if that's true. Just print anything you like as long as we can easily spot it in the console. All right. Let's see. We wouldn't expect it to work out because so far there's no explicit connection between the image picker and the sign-up view controller, except the sign-up view controller presents the picker controller. We probably need something more. All right, let's tap the image view to display the image picker. Now, let's pick a photo, then look at the console. Okay. All right, nothing happened indeed. Let's step back to see what we've done. We let the sign-up view controller conform these protocols in the hope that it can access the photos selected by the image picker. However, to access media files selected by an image picker, one must be a delegate of that image picker controller. Fortunately, this delegate is of type UI image picker controller delegate and UI navigation controller delegate. And the sign-up view controller already conforms to these protocols, which is good. So the only thing left is that we let the image picker know that we want the sign-up view controller to be its delegate by assigning self to the delegate of the image picker. That means self is now the delegate of the image picker we use. So now it's able to implement the methods in these two protocols to get access to the selected media files. Okay, good. Let's check it out. Okay. All right. Okay. And okay. Let's present an image picker and choose a photo in the photo library. Fantastic. The method in the extension was executed indeed, but the app is kind of bad now because the photo library doesn't go away. So let's dismiss the image picker after we're done. The two parameters will be the same as in the present method we use above. All right, good. Let's run the app again. Okay. All right. Okay. Okay. All right, let's do it again. Here's the photo library. Pick a photo. Excellent. All right, now we can access the picked photo. How to extract it and what it does look like, we'll talk about shortly. But let's set a small goal first. After we can extract the photo, our first job is to display it on the UI image view. Let's say we have it. We need to assign it to the image property of the UI image. If you look at the parameters of this function, it can be easily seen that our picked photo should be in the info parameter. Although now we don't have it yet, let's just give it a name like info photo. Great. Now let's see how we can extract it from the return stuff from the image picker. First, let's define a constant to hold the image we're going to extract. We know that we should extract it from the info parameter. Okay. Xcode doesn't give me any suggestions. All right, well, no problem. In this case, we can just print out this thing to see what it contains. So let's print info to see how we can extract the selected photo from it. All right, let's run the app and see. Okay. Okay. Actually, let's comment this line because info photo doesn't exit. Okay. Okay. All right. Okay, let's pick a photo again and see what we receive exactly by implementing those protocols of the image picker controller. In the console, we can see how the info parameter looks like. What we're looking for is probably the value of this key UI image picker controller original image. You can see that info is a dictionary of type string and any object. String key, value, string key, value. String key, and the value is a UI image object. So let's extract this image using this key. Info is a dictionary. We're going to get the value corresponding to the key UI image picker controller original image. All right, you can see in the parameter list of this function, info is a dictionary of type string and any. So we need to cast this value into a UI image object. Okay. All right, this should be a UI image as you can see in the console. Now, we can extract this picked photo. Let's display it on the UI profile image by assigning it to the image property of the profile image variable. Okay. All right, let's see. Okay. Okay. Now let's pick an image to see if we can display it as a profile photo on the sign-up view. Wonderful. All right, we now can choose a profile photo and show users what they've just selected. Now our final big step is to store this profile photo on Firebase, to tie it up with the other information of the user. As a tiny transition step, let's create an instance variable of the sign-up view controller to store this selected. We're going to name it selected image, and it should be of type optional UI image, because users are allowed to not choose a profile photo. All right, let's see where we should make this assignment. Okay, we can only assign the picked photo to this new variable once users select the photo. That is, when this method gets called and the selected photo can be accessed via this info dictionary. So we should assign it to the new variable here. Okay. Right. Okay, good. Now we'll send this selected image to Firebase. As we mentioned before, we're going to store all media files to Firebase storage, then link them to Firebase database to utilize its real-time data handling feature. So, as usual, let's define a constant pointing to where the Firebase storage of our project lives. Similar to others, we probably can use... Alright, we installed the storage package but haven't imported it into our project. So let's do that. Alright, similar to others, the main tools for working with Firebase storage are provided by the class FIR_storage. Let's create an instance of this class to use the tools. Then we can use the reference method to get access to the root location of the Firebase storage of our project. The usage is very similar to other Firebase packages we used. This storage ref constant is now a sort of Firebase referencing object, which points to the root location where the Firebase storage of our app lives. Okay. Before moving on, let's think a little bit about how we should proceed. Actually, let's go to Firebase to see the storage of our project. Okay. All right, here's our storage. This is the root location, which the storage ref constant points to. Eventually, we'd want to store all kinds of other media data there, like posted photos and videos. So we'll organize this place in directory structure, just like in the database. Okay, once you get familiar with this stuff, you can chain everything into a single command. First, another way of getting this root location is simply saying it out loud. So we can use another method which requires which location we want to point to as an input. Okay, so simply use the URL of the root location as the input of this method, in string format to point to this root address. Just another way of getting the root location. Alright, in this location, let's create a node containing profile photos of all users. You can name it whatever you want. Here, we simply name it profile image. Later on, we'll have other nodes like posted photos, posted videos, or things like that. We're going to store all profile photos in this node. For each newly signed up users, we'll create a child node of this profile image node to store the profile photo of that new user. Now, this photo should tie up to the corresponding new user, so we should use some information of that user for the relative path of this node. And as before, using Firebase user ID is the perfect choice. Okay, the error is easy to fix. User ID is optional, so we need to unwrap it. But because we also use this ID when creating the user on the database, so let's define this user ID constant once, then use it in both places. All right, good. Now we have a place on Firebase to store each of the new profile photos. We now need to push it to this location, referenced by this storage ref constant. The newly chosen profile image is stored in the selected image variable, which is an optional UI image as you can see here. So we use optional chaining to access its value. Let's name this value profile image. It should be the value of the selected image. Okay. By the way, we can also use the image property of the UI image, but we're going to use that for displaying purposes only, and use the selected image variable to keep track of the chosen photo. All right. The profile image constant here is now a UI image. We're going to need to convert it into a Firebase friendly format. Let's define a constant to hold that converted data. Say image data. All right, let's see. Firebase stores image data in a JPEG format, so let's find a function to get the JPEG representation of a UI image. Okay, UI image, JPEG. Okay, here it is. This function will convert our UI image in the Firebase friendly format we talked about. It has two inputs. The first one is a UI image view. In this case, we simply input the profile image constant we've created before, because we're trying to convert it into JPEG format. Okay. All right, sounds good. Next, we specify how good we want the resulting photo to be, comparing it to the original. Here we use a 0.1 compression ratio to get a lightweight photo. All right. There's some errors and warnings, but let's think about them. We'll come back shortly. Now, we have the selected image in a format that Firebase likes. So let's put it to the storage location we created for it. There are three methods we can use, named put_upload_data. The simplest one simply uploads data. The one in the middle returns some meta information that we can use later. And the final one also lets us do something after the process finishes. Now, the upload data is simply our image data. Actually, let's see how to use this function properly. This is the uploaded data. Metadata is simply any additional information you want to tag to this data. Here, we don't have any. And finally, completion is simply the block in which we perform anything we want after this uploading process finishes. All right, this will be nil because we don't need to upload any extra information. Now what we receive back in this closure is some metadata information of what we uploaded, and error if the uploading process failed. All right, before moving on, let's fix this annoying error. We're still operating in the closure in the create user function, so we need a keyword self for instance variables. By the way, note that this profile image constant here is this one. It doesn't require the self keyword, because it's not a property of this signup view controller. All right. It's actually different from the IB outlet property profile image we use for the UI image view on the signup view. So to avoid any confusion, let's change the name of this constant to something else. Say profile img. Okay, now back to our business. First, the two metadata here are different. One is the extra information we upload together with the uploaded data, and the other is what Firebase gives us after the uploading process. This process might fail, so let's check if that's the case. If yes, then just return to break from this uploading function, and ignore anything below in this method. Otherwise, we're going to get back some information of the uploaded data in the metadata parameter. An important information is the URL where our data lives. We'll extract that information into this profile image URL constant from the metadata. Now, search for download or URL. We're going to see that this download URL method does the job. And finally, let's convert this URL into a string using this suggested property. This simply returns the string format of the URL of the data. Okay, so why do we need it in string format? Recall that our last step is to tie up this profile photo in Firebase storage with the corresponding user in Firebase database. So we'll store this URL as a piece of information of the user along with the username and email. As we're storing user information in string dictionaries, we're going to need this URL in string format. All right, let's move this database stuff to a good place. Let's move it to the closure above after we get the URL string. Okay, now simply append the profile image URL string to the user information dictionary to push it to the database. For the key, let's choose something related to profile photo. Here we simply use the profile image URL. This is just a literal string. It has nothing to do with the profile image URL constant. Okay, let's delete the unnecessary printing stuff and make the code look nicer. All right. Okay, let's see. We're good. Now check it out. Okay. All right. Actually, let's go to Firebase to see everything in real time. This is Firebase storage for our project. This is Firebase database. It's loading existing data. All right. Now, let's create a new user. Let's choose a profile photo for this new user. This one looks good. For username, let's say user4. For email, let's say user4@gmail.com. And 1, 2, 3, 4, 5, 6 for password. Good. Let's hit the sign up button. Fantastic. Let's check out this new user. All right, great. Here's the information of the new user we've just created. This is the URL string of the profile image. It's just a URL, so we can view it in a browser. Okay, it's a string, not a URL, because that's how we store it. So let's delete these quotation marks. Okay, good. Let's see. All right, great. We got the photo. Let's open it. Wonderful. This is exactly the profile photo we used for the new user. Finally, let's see if it indeed physically lives on Firebase storage. Okay. All right. Okay, here's the profile image folder or node, which contains all profile photos. This is our profile photo. Our photo lives here physically. The URL string we store in Firebase database is simply something we can use to access this data. If you click the file, you can see some information of the file. If you print the storage ref constant in the source code, this is what you get. And the download URL below is what we extracted from the returned metadata in the closure. It's also the one we stored in Firebase database, which we've just used to preview the data. Okay, not this one. Let's see. Okay, it's this one. It's simply the URL to where our data physically lives. All right, see you next time.